Chapter 4, Section 4, Graphing a Function Rule. So copy down the following example. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown on the next slide. We're asked to write a function and graph for each situation and then tell whether it's continuous or discrete. So this is what I want you to make a note of here. Continuous means you connect the points. Discrete means you leave them as points. So in other words, we're talking about whole numbers, or are we talking about fractions? If we're talking about every number in between the points, then we connect them. If we're talking about just the points being answers, then we leave them as points. We don't connect them. So we have the weight W of the cheese in ounces depends on the number of gallons of milk M, which is used. 1 gallon of milk makes 16 ounces of cheese. So we're talking about two separate situations. Each one is going to have its own graph and each one is going to have its own table. So first we're going to look at the weight W and the ounces depends on the number of gallons. Well, they're telling us that the weight W depends on the number of gallons, which means the weight is going to be our Y and the amount of gallons, M, is going to be our X, our independent. Well, let's say you have 0 gallons of milk, that's going to make 0 ounces of cheese. If you have 1 gallon of milk, that's going to make 16 ounces of cheese. 2 gallons will make 32 ounces. 3 gallons will make 48 ounces. And 4 gallons will make 64 ounces. On the other table, the amount A of money from selling cheese depends on the number N of wheels. So the amount is the dependent and the number is the independent. Well, if you have 0 wheels, you make $0. If you have 1 wheel, you sell each one for $9, which means 2 will be for $18, 3 will be for $27, and 4 will be for $36. So we can see that the relationship here is that W, the weight, equals 16 times the number of gallons. Whereas in the other one, the amount that you make is $9 per wheel of cheese. So we have our two equations that we're going to graph. If we wrote them as functions, it would be a function of the independent variable equals 16m, and a function of the independent variable equals 9n. So these are two separate functions. So on two separate graphs, I want you to just draw the first quadrant. We have our weight of cheese titled graph and our money earned titled graph. Here on the x-axis, I counted by ones, and I labeled it M because we're using M instead. And here is weight, which was labeled W. Here, our highest number goes up to 64. So you can count by different things, but here I just counted by 32s, and I skipped a line in between, 2 lines in between each interval. Here, again counted by 5s on the bottom, titled it Wheels Sold and Amount of Money, S. Remember the arrows at the ends of the lines? I counted by 18. Again, skip 2 lines in between each one, just to spread it out, because you don't want the points to be right on top of one another. Now here, you plot the points. We're saying that this is a continuous graph. It's continuous because any amount of milk makes sense. You can use half a gallon. You can use 1.5 gallons. It'll just produce more cheese than 1 gallon. But in this case, it's discrete because you can't go to the supermarket, cut half of a wheel of cheese off and say, well, I only want to pay half for it. That doesn't make sense. You can either buy 0, 1, 2, 3, or 4. You can't buy half of a wheel of cheese. You can't go over and cut one of them in half and take 1.5 wheels home. It doesn't make sense. They're being sold as whole numbers. So this would be discrete. You're not connecting the points. Next, we just have a few functions that we're going to graph. So I'm going to start off, since we're graphing functions, by labeling this f of x and this x. So instead of x and y, it's f of x and x. Now, let's pick a few x values to start out with. Well, we see that the first one is using absolute value. So we want to see what happens when x is negative. So let's say -2, -1, 0, 1, and 2, and see what it's like when it's positive. Well, when we plug in -2, the function at -2, the absolute value of a -2 is +2, and +2 plus 1 is 3. So when you plug something into absolute value, you take the positive version of it. So the absolute value of -1 is +1, plus 1 is 2. Absolute value of 0 is 0, plus 1 is 1. Absolute value of 1 is 1, plus 1 is 2. And then absolute value of 2 is 2, plus 1 is 3. So we're going to plot these points on our graph. Well, I'm just going to number it by ones. So 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. And then the bottom is down here. So -2, 3 gives us this point. -1, 2. 0, 1. 1, 2. And 2, 3. Notice that it makes a V shape. Every time we have an absolute value function, it's going to make a V shape. Make sure you use a straight edge to connect everything. And then make sure you label it as f of x equals absolute value of x plus 1. Now we want to have the negative numbers there, because if we didn't, all you would see is the right side of the graph and it would look linear. But by looking at the table, we can tell it's decreasing by 1, it's decreasing by 1, then it's increasing by 1. It's not a constant rate of change, so we have to show both sides. We have to be able to show the full shape. So whenever you have absolute value, it should be making a V. Now let's try the next. So x squared. This obviously isn't linear either, but now we're working with y equals, so now I'm going to label it y and x. Well, again, let's see what it's like on the negative side as well. So let's start with -2, -1, 0, 1, and 2. -2 squared, this means -2 in parentheses squared. -2 times -2 is 4. -1 times itself is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Well, again, we can count by 2's here. So skip a line in between. This is 2, 4, -2, -4, -2, -4, 2, and 4. We're going to plot -2, +4, -1, +1, 0, 0, 1, 1, and 2, 4. Notice this isn't a V shape. It's not coming out in this direction and making a perfect V. This is called a parabola. It's a U shape, and we're going to talk more about this later in the year. Arrows at the ends. Make sure it's hard on the iPad, but make sure that both sides are symmetric. It should be a perfect U. You should be able to fold it along the y-axis, and it should be symmetric to both sides. And then just label it, since we're working with an equation, as y equals x squared. Finally, we have y equals x squared plus 2. So again, it's an equation because it's y and x, so we're going to label y and x. Again, it's not linear, so let's start out with -2, -1, 0, 1, and 2. -2 times -2 is 4, plus 2 is 6. -1 squared is 1, plus 2 is 3. 0 squared plus 2 is 2. 1 squared plus 2 is 3, and 2 squared plus 2 is 6. So our graph has to go up to 6. So now let's count by 2's on each line. So don't skip a line. So 2, 4, 6, 8. 2, 4, 6, 8. -2, -4, -6, -8. -2, -4, -6, -8. Well, we're going to plot our first point. So -2, 6. -1, 3. It's in between the -2 and the 0 here and here, and then in between the 4 and the 2 here and here. 0, 2, 1, 3, and 2, 6. Notice that you have this point here, and then our points in this case are directly across from one another. When you connect it into that parabola, into that U shape, it should still look like that symmetric shape. And then we're going to label it as y equals x squared plus 2.